Hi everyone and welcome to the 5th annual Golden Gate Science Olympiad Invitational. My name is Evelyn and I'm currently a senior at Stanford majoring in human biology, and I am one of the executive directors this year.
Hi, I'm Matt, and I'm a junior at UC Berkeley majoring in electrical engineering and computer science, and I'm the other executive director.
First of all, we would like to thank all of you for your patience this year as we navigate this new form of Science Olympiad. This may have been a challenging year for all of us as we adapted to these online models, but we are moved to see how passionate students continue to be about Science Olympiad.
Since its creation 5 years ago, Golden Gate Science Olympiad has been dedicated to inspire students to pursue STEM by running a high-quality Science Olympiad Invitational, organized by Science Olympiad alumni. This pandemic has made it clear that STEM is more important now than ever. The COVID-19 vaccine has been developed in groundbreaking time. Engineering solutions have created new ways to protect ourselves from the virus, and technological advancements have made it easier to connect with people from a distance. The fact that we've been able to host 150 teams this year, 3 times the number of teams as compared to previous years, reflects this urgency.
It would not have been possible to run an invitational of this size without help. We first want to thank our wonderful sponsors: Stanford School of Earth, Energy, and Environmental Sciences, Lawrence Livermore National Laboratory, the Gordon and Betty Moore Foundation, Chemical and Systems Biology at Stanford, and professional engineers in California government.
We would also like to thank all of our volunteers and event supervisors. They've put in a ton of time and effort, and without them, this tournament would not have been possible.
Also, a shout out to the most amazing board of tournament directors: Allison Yao, Faith Heron, Amy Jiang, Emily Wen, Martin Altenberg, Sophia Wang, Vinay Gautam, Brittany Wang, Philip Lee, Nikhil Gupta, Arya Sharma, Iris Shah, Nicole Shin, and Alvin Shu. We've been planning this tournament since February 22nd of 2020, our competition last year, so a huge thank you to their dedication to this tournament.
Finally, we want to thank all of you, the coaches, parents, supporters, and competitors. We are proud to have teams from 20 different states across the nation. We applaud your commitment to Science Olympiad, especially during these times. And students, we cannot wait to see what's in store for your futures.
And now we'd like to introduce our first speaker, Dr. Dustin Schroeder. Dr. Schroeder is an assistant professor of geophysics and electrical engineering at Stanford University. His research focuses on the interplay between subglacial water, continental ice sheets, and sea level rise, especially using geophysical radar remote sensing techniques. He also chairs the National Science Olympiad Earth and Space Science Committee. Dr. Schroeder has been a mentor for GGSO since its inception, and we are grateful for his continued support over the years.
Hi, everyone. I'm Dusty Schroeder. I'm an assistant professor of geophysics and by courtesy of electrical engineering at Stanford. And I use ice penetrating radar to study Earth's ice sheets and the icy moons of Jupiter. I'm also the chair of the Earth and Space Sciences Committee for the National Science Olympiad. And most importantly, I'm the faculty advisor for this Golden Gate Science Olympiad Invitational. So I wanted to take this opportunity to welcome you to this virtual invitational and to say how proud I and the Stanford School of Earth, Energy, and Environmental Sciences are of being a sponsor for this tournament. I also want to point out how great a job everyone did in running this tournament in this online format. This is the first year it was done this way, and this has allowed 3 times as many students to participate. And I think it's a really impressive feat what the team has done here. One of the reasons that I'm so thrilled to be the faculty advisor for this tournament is the profound impact the Science Olympiad has had on my life. I was the first person in my family to go to college, so Science Olympiad was how I first got exposed to engineering and science and the idea of going to college in the first place. I was not a particularly good student, probably worse than all of you watching this video. as a freshman in high school. I had like a C- in Algebra 2 and a 2.6 GPA or something. But I really liked building things. My dad was an appliance repairman and we had a shop in my basement. And so I started in Science Olympia by competing in the building events like Scrambler, which is this event that even then you built a car that carried an egg to go at a wall as close as you could and stop without smashing the egg. And for me, as I was trying to make that car go as fast as it could, I found that I needed to take, or I thought I needed to take the derivative of a parametric function to make the gears have the optimal ratio. So I went to my Algebra 2 teacher and I was like, I need to take the derivative of a parametric function. And he was like, man, you are barely above a D in this class. How do you even know what the derivative of a parametric function is? But I think for me, learning that and realizing that the things I was learning in school could help me build cooler things and design things that there was some use to it got me really excited about school, but more excited about Science Olympiad. After that, I got interested in astronomy and observational science, which is a lot of what I do today. And even that interest came just from Science Olympiad. Our team did not have anyone who was good at astronomy. And I was a competitive kid on a good Science Olympiad team. So I was, captain of my middle school team. So I just started doing astronomy. And through that, I started volunteering at the Cleveland Museum of Natural History in the planetarium. And through that, I joined the Cleveland Astronomical Society, where I would once a month hang out with these, I think I was like 16 and the next youngest person was like 60. And my parents would drop me off in the park with these old people eating mashed potatoes and talking about astronomy. And I think that they must have been super weirded out by that. But I went and I learned a lot about astronomy. And luckily for me, right after I won my first national championship in Reach for the Stars, I was at one of those meetings in the park, and there was a guest speaker from from Case Western Reserve University in Cleveland, who invited me to do research in his lab. And through doing research in his lab, I got exposed to people who went to college, who studied physics. I got exposed to the fact that there were people whose jobs were just to think things up and to discover things. And that had a tremendous impact on my life. I mean, I think even looking at that, the fact that I competed in Science Olympiad building events and astronomy, led to this love of building things and doing observational science, which is what I do now. We build radars to look at ice sheets, and we use data from radar to understand and interpret and model what's going on in the ice sheets. It's this love of both engineering and science that I definitely developed in Science Olympiad. Also, I mean, another profound similarity to Science Olympiad is the idea that you build stuff and then you go somewhere else, and things that worked in the lab or at home don't work. I think my experience of building radars to take to Greenland and Antarctica is a great deal like competing in Mission Possible. You test something in the lab, it works great, and you ship it off. Then you get there and it doesn't work. You spend all your time trying to figure out what didn't happen. What was different, what broke, how do you repair it in the field? All the more so, with space missions. I'm on NASA's Europa Clipper mission. I'm a science team member there. And in that case, we can't even really test it at home. We don't get to deploy the whole spacecraft on Earth with all the instruments interacting with each other and all the solar panels deployed. So we have to test them individually. And then, rather than ship or fly with your device to a tournament, we got to put it on a rocket and launch it to Jupiter, which is a very different environment than where it was tested. So I think, yeah, if you are really enjoying Science Olympiad and really enjoying building events and are into the idea of like a version of Scrambler or Mission Possible that costs like $2 billion and then you ship to Jupiter, then I think you might really like working on NASA missions. The other parallel I'm struck with Science Olympiad all the time is how much, even though it's about science, that getting things done, that leading a Science Olympiad team, that doing Antarctic field work, that leading a research group, that being part of a NASA mission is really about people and leadership. I think those of you who are captains of your team know that a lot of what lets your team succeed at a tournament is navigating schedule conflicts, is helping encourage people who've had a bad event, is dealing with partners who hate each other, or maybe have started dating, or maybe broke up, or getting someone like anyone to be interested in Right at Do It. These are people skill challenges that really lets a team thrive, and it's all the same things in leading a research group. It's, building a team, understanding and supporting each other, overcoming setbacks. On a NASA mission, even more so, it comes to helping all these smart scientists and engineers work together on their individual pieces with their individual personalities to accomplish something big. So, I guess the good news is, if you really love Science Olympiad and you're not sure what you're going to do once you graduate, actually a lot of careers in science and engineering can be a lot more like just a professional version of Science Olympiad than you'd imagine. And the leadership skills you're developing here can do amazing things in whatever area you choose to pursue, like this tournament. All of these students are people who had competed in Science Olympiad and are using those skills as a competitor to host something like this. So yeah, I'll close with saying just how impressed and proud I am, and the whole Stanford School of Earth, Energy, and Environmental Sciences are to be sponsors of this tournament. How proud we are of the organizers of the tournament and pulling this off in such a tough year, and how proud we are of you as competitors and continuing to rise to the occasion and navigate this new way of competing. And that I hope you make as much of your time in Science Olympiad as you can, and that it changes and enriches your life as much as it has mine. So congratulations, everyone, and I look forward to seeing you in person next year. Thanks.
Thank you, Dr. Schroeder. Our next speaker is Dr. Alex Filipenko, who will be giving our keynote address this year. Dr. Filipenko is a Richland Rhoda Goldman Distinguished Professor in the Physical Sciences and a Miller Senior Fellow in the Miller Institute for Basic Research in Science. His accomplishments have been documented in about 960 research papers and have been recognized by several major prizes, including a share of both the Gruber Cosmology Prize and the Breakthrough Prize in Fundamental Physics. One of the world's most highly cited astronomers, he is an elected member of the National Academy of Sciences and the American Academy of Arts and Sciences. He has won the most prestigious teaching awards at UC Berkeley and has also been voted the best professor on campus a record 9 times.
Hi, I'm Alex Filipenko, an astrophysicist at UC Berkeley, and it's my great pleasure to have been selected as the keynote speaker for the awards ceremony of the 5th annual Golden Gate Science Olympiad Invitational Tournament. Wow, that's a real mouthful. I want to congratulate all of the students who participated in this exciting event. You're among the brightest and most enthusiastic young scientists, and we look forward to seeing you continue to flourish. STEM fields are enormously important now in our increasingly high-tech world, and our nation really needs to attract more high school and college students to pursue them. The Science Olympiad is a great way to get high school students even more involved in STEM fields. So I'd like to thank the UC Berkeley and Stanford undergraduate students for organizing it, as well as, of course, the parents, coaches, and other supporters of the participants. I'm really sorry that the tournament had to be conducted virtually this year owing to the COVID-19 pandemic, but I hope it was still able to sustain the same spirit of cooperation, learning, and excitement that past tournaments have fostered. I was asked to talk about my personal path to becoming a leader in science and science communication, highlighting some turning points in my career, and I'm really happy to do so. Perhaps my story will serve to further inspire some of you to continue in STEM fields. So let me turn off, let me turn on the screen sharing here and go to my PowerPoint presentation and start it. Okay, great. So this is my journey in the accelerating universe. So I was born in 1958 in Berkeley, California, when my father was a mathematics graduate student there and my mother was in library school. Here I am with my brother Ivan. And here I am perhaps worrying about what the dark energy is that is accelerating the expansion of the universe. I don't know. I grew up being strolled around the Berkeley campus. So now that I'm a faculty member here, it's sort of like a homecoming. But when I was about 6, we moved to Santa Barbara, and after a year to Goleta, which is next to Santa Barbara, and I grew up there. And my first interest in science was cultivated by a fascination with magnets. I just could feel the force, but I didn't know what it was. I resolved to someday understand it. But I was interested in other sciences as well. You know, I played with various electronics kits. They weren't so sophisticated back then. I was interested in insects and watched ants wander around for hours. I got a microscope and was introduced to the micro world of amoebas and paramecia. And I got a chemistry set at age 10. And from age 10 through 17, that was actually my main interest, chemistry. I spent every dime that I earned on a pretty well-equipped home chemistry lab. I did some legitimate experiments, but I also played with explosives. And here I am as a senior, president of the high school science club, you know, lighting up some flash powder or something. I actually had some pretty bad accidents. There was one in particular where, you know, had I not been wearing glasses, my eyes probably would not have survived. So, you know, that was a lesson, but I didn't learn it super well because I had other accidents as well. When I was a freshman in high school, my parents gave me a small telescope as a birthday gift. And that first night, I took it outside, looked at a bright star. It looked even brighter. That was kind of a thrill, my first view of a star through a telescope. I then looked at another star and it looked brighter too. So the novelty was beginning to wear off. But before putting the telescope away, I decided to look at a third star. And that star looked kind of jittery and fuzzy, and I let the jitters die down in the telescope, and I realized that I was looking at Saturn. Now, that night, I discovered Saturn on my own. It didn't matter that millions of people had seen it before me. No one told me to point at that bright star. So I thought, wow, if I can get such a great thrill out of discovering something that everyone else already knows about, what amazing thrill would it be to truly discover something new in science? The nature of the physical world. That must be really fun. So I resolved at that point to become a scientist. Still, my main interest was chemistry, so I entered college as a chemistry major at UC Santa Barbara. I had won the first prize in a prize exam that college gave, and so that gave me a scholarship. So I spent a lot of time in the Department of Chemistry my freshman year. But at the end of my freshman year, I switched to the physics major with the intention of becoming an astrophysicist. And that was really for 3 reasons. First, in one's sophomore year, one had to take organic chemistry. And I wasn't that interested in organic chemistry. I liked physical chemistry and quantum chemistry. Plus, the fume hoods back then weren't very good. And every time I went past the chemistry lab, I could smell all these noxious fumes coming out. Secondly, in my freshman year in college, I had another pretty bad accident that could have easily blinded me had I not been wearing glasses. So I figured, well, if nothing but as out of a sense of self-preservation, I've got to get out of this field, okay? And thirdly, as a freshman, I took an introductory course on astronomy, where my professor, Stan Peele, taught me that the structure of the universe as a whole and the nature of big things like stars, those are determined by the physical properties and behavior of matter at the smallest scales. So by doing astrophysics, I could have it all, the very small and the very large. I was allowed to teach a course in the College of Creative Studies, the same course that I had taken from Professor Peele, and that gave me a chance to really experience how fun it is to teach people about the universe, and in particular about astronomy. And so a lifelong love of teaching, of educating the public, developed as a result of teaching that course twice, actually, as an undergraduate. And I've been at Cal now for 35 years, teaching and doing research, of course. And my favorite class is the introductory class on astronomy for about 850 undergraduates, where it's a real thrill to show them the grandeur of science and what it is we do and how we go about it. Those things are actually more important than the facts themselves. Well, I've also done a number of documentaries bringing science to the general public. Those are a lot of fun, but it's also a lot of work. You sit there for hours being interviewed for what end up being just a few minutes of screen time. But still, it's a chance to educate the public, and I've been grateful for those opportunities. I've also co-written a textbook with Jay Pasakoff. It's now in its 5th edition, The Cosmos, Astronomy in the New Millennium. That was a lot of work too, but also rewarding. And then I've done a bunch of video courses with a company called The Great Courses. This one, a 96 half-hour lecture series on introductory astronomy, actually nearly killed me because I was working on research and other things at about the same time. I had 2 shorter courses, one on black holes and one on sky watching, seeing and understanding cosmic wonders. Features of the daytime sky and the nighttime sky, like auroras and eclipses and their physical explanations. Well, back to my undergraduate years, in my senior year, Stan Peele used classical physics to calculate that the innermost moon of Jupiter, called Io, would be stretched and squeezed by the changing gravity as a result of Io's slightly elliptical orbit. And that should melt the interior of Io, and it should show rampant volcanism on its surface. And his prediction was published just a few days before the Voyager flyby past Jupiter. And it confirmed that Io had this incredible surface. Look at that, it looks like a pizza. It's dominated by volcanism. In this picture, you can even see a volcano here at the edge. So I vicariously lived through this thrill of a truly new discovery through my advisor. And, again, it was a transformative moment. It just made me feel like, wow, I really want to participate in this great thing called scientific discovery. So it was fantastic. Stan Peele also took me to see my first total solar eclipse in Oregon, and it was really cloudy up until when the partial phases began, and then the clouds slowly cleared away. They're still there quite late into the partial phases, but just as the diamond ring effect was happening, the last cloud cleared away and we got a beautiful view of the corona. And my goodness, this was such a moving experience. I know I sound like a nut, but you've got to put seeing a total solar eclipse on your bucket list, okay? It's just fantastic. Some of you may have seen the one a few years ago, 4 years ago, in 2017. I went to Oregon near the place where I had seen my first one, and that was really a spectacular sight. So, if you haven't seen one, put April 8th, 2024 on your calendar. There will be one that goes over a good fraction of the US. Be in the path of totality. If you're away from the path of totality, you'll only get a partial eclipse. And that's an interesting, geometrical curiosity, but it's nowhere near the grandeur of a total solar eclipse. So be there or be square. You'll thank me for emphasizing this and for forcing you to go or encouraging you to go. All right, well, because of Stan, I also got 2 summer jobs in the summers of 77 and 78 as an undergraduate at the University of California's Lick Observatory. And that's because Stan knew Don Osterbrock, the director at the time. And I gave tours of the great James Lick 36-inch refractor, under which the body of James Lick is currently located. I also sold postcards and other various things in the gift shop. It wasn't so well equipped long ago, but here it is, more modern view. Well, I got to do research with the 12-inch Clark refractor at night, and I studied, along with Richard Simon, another undergraduate, a globular cluster, a giant conglomeration of hundreds of thousands of stars. There's about 150 of these things that orbit our galaxy. And we studied a particular type of variable star, in those globular clusters. They're called RR Lyrae stars. And if you look at them long enough, you can actually see that they're evolving with time. And indeed, a few of my undergraduates just completed a project where they redid this study with new data and showed that some of the periods of pulsation had changed. I went to grad school at Caltech in Pasadena, largely because they had, they owned Palomar Observatory. And I worked with Wal Sargent at Caltech. I was interested in really energetic phenomena called quasars. These are supermassive black holes at the centers of galaxies, and they're gradually eating the gas around them, and they cause that gas to heat up and glow very energetically as it's being swallowed by the black hole. But as the gas gets used up, the glowing of the gas subsides and the nucleus becomes less bright. Then it becomes a more normal active galaxy, a Seyfert galaxy. And I decided to try to find very low level activity of this sort in the centers of essentially normal galaxies. So I did a survey of the 500 brightest galaxies in the Northern Hemisphere using the great Hale 5-meter telescope, the big eye at Palomar Observatory. Well, we would take spectra of the centers of the galaxies. That is, we'd pass the light through a prism or a similar device and spread the light out into a rainbow. And from studies of that rainbow, you can tell whether you're looking at an active galaxy or normal stars or whatnot. And in fact, here is one of the least luminous active galaxies that we found, this one here. And it was really kind of a thrill to find this one. Well, in August of 1984, after I finished my thesis, I moved to UC Berkeley as a postdoc. Go Bears, all right. And I was actually a Miller Fellow in the Miller Institute for Basic Research in Science. My mentor was Hiram Spinrad, and we used the Lick 3-meter telescope to study all kinds of distant galaxies and other interesting things. Nevertheless, I was still also using the Palomar 5-meter telescope at the time in order to finish observations of this set of 500 galaxies that I started observing for my doctoral thesis. And near the end of a 5-night run in February of 1985, we had hundreds of target galaxies still to look at. I happened to choose one at random, NGC 4618, and that one had an extra star that didn't seem to belong. It wasn't in previous photographs of that galaxy. So we took a spectrum and it turned out to be an exploding star, a supernova. And so not only did I discover an exploding star, but it turned out this was a new weird variety that had not actually been recognized before. So that was, really fun. And it got me on the road to studying these colossal explosions. Just a couple of years later, there was supernova 1987A, the first supernova of 1987. And that was the brightest supernova in about 400 years. And it was studied throughout the electromagnetic spectrum. So that was a real thrill that that thing came along. But the power of a supernova is shown here. Here's a galaxy with 100 billion stars and a single star blowing up. And you can see that at its brightest, it's about as bright as the central few billion normal stars in that galaxy. So these things are really powerful. If our sun were to explode, which it won't, then sunblock of 50 just wouldn't cut it, folks. You'd need sunblock or supernova block of a few billion to protect yourself. But don't worry, it's not going to happen. Our sun will die much more quietly. Well, at Berkeley and Lick Observatory, we developed this rather small telescope, Kate we call it, which would take pictures of over 1,000 galaxies a night and then repeat the process for the same galaxies a few nights later. And we would compare the before and after pictures of the galaxies, and usually there'd be nothing new, but occasionally there would be something new, a supernova. And there you can see a supernova candidate. We would get 1 or 2 dozen candidates out of 1,000 images each night. And then undergraduates with their superb eye-brain combination would examine those candidates and would determine which ones are likely to be genuine supernovae worthy of further study by our team. And, they got really engaged in research. They got to experience the thrill of research at an early age. I encourage you to get involved in research as early as you can in college. Well, the studies of supernovae brought me to study the expansion of the universe and to participate in this amazing discovery of the accelerating expansion of the universe. So briefly, about a century ago, Vesto Slipher studied spiral nebulae, and he noticed that most of them are moving away from us. And then Edwin Hubble determined their distances and found that the nearby galaxies are moving away pretty quickly, but the more distant galaxies are moving away even more quickly. And this led to the idea that the universe is expanding. And the modern view is that the space between galaxies is expanding, and that's what's causing the light to expand and become redshifted like this. It goes from being blue, or starting out as blue, to becoming progressively redder. So that's the expansion of the universe. Now, today we know pretty well the current rate of expansion, although there's a puzzle that I'll tell you about in a few minutes. But we expect the rate of expansion to be changing with time. And that's just because of gravity. Just as Newton saw an apple fall from the apple tree and wondered what it is that pulls on it, well, it's gravity. And so too, the gravitational attraction between galaxies, and here you see thousands of galaxies, should be gradually slowing down the expansion of the universe. And if the density of matter is sufficiently great, the expansion will someday stop and turn around, and you'll get a big crunch. Or if the expansion is quick and the gravity isn't too great, then the expansion could continue forever, albeit at a progressively slower rate, because gravity doesn't stop acting on the galaxies even when they're far away from each other. Well, if you measure the expansion history of the universe, you can determine the fate, big crunch or eternal expansion. So we set out to do that by comparing the brightnesses of nearby supernovae, whose distance we know, with the brightnesses of very distant supernovae. We could get the distances of those supernovae, and hence the look back time, how far back into the past we're looking. And by comparing the look back time with the redshift, we could trace the expansion history of the universe. And what we found, much to our surprise, is that the universe hasn't been slowing down, it's been speeding up. And I was the one member on both teams that got spectra of the supernova candidates and measured their redshifts and so on. I also was the first to be able to announce this result at a meeting in LA in February of 1998. So that was a lot of fun. Astronomers see a cosmic anti-gravity force at work. Well, we don't know the cause of this anti-gravity. We call it dark energy. And we now know that it constitutes 70% of the matter plus energy contents of the universe. And we don't really know what it is. And dark matter, which holds galaxies and clusters of galaxies, is 25%. We don't know what that is either. We only know the ordinary matter. So if anyone tells you that astrophysics is done, there's nothing left to be discovered, you tell them, well, what about the true origin and nature of 95% of the universe? By 2011, this discovery of the accelerating universe had been confirmed by other astrophysicists using other techniques, and it was recognized with the Nobel Prize in Physics. To our team leaders, Saul Perlmutter in the middle there of Berkeley, Brian Schmidt on the right of Australia, and Adam Rees on the left, who was my postdoctoral scholar in the mid-1990s and was the first on Schmidt's team to recognize what the data were trying to tell us. Now, we all got invited to the Nobel Week in December of 2011, and here's the Schmidt team right after the award of the prize. Here's Saul Perlmutter's team. I'm not in that photo, I should be, but at that time, the High Z team, the High Redshift team, was having its celebratory lunch, and I was more closely affiliated with that team. And at that lunch, my wife revealed her consolation prize for all of us who did not technically win the Nobel Prize, because it can go to a maximum of 3 people. And that consolation prize was the t-shirt, "Dark Energy is the New Black," a limited edition. Well, later on, we all won the Breakthrough Prize in Fundamental Physics, where all members were recognized officially. And that was really great. It's nice to get the recognition. But really, we do science not for the prizes, but for the thrill of discovery, for the privilege of contributing to our understanding of the universe. And never in my wildest dreams as a kid did I think that I would be involved in such an important discovery. That has been the real thrill of my life, of my professional life. So it's just great. Well, we've been studying the past history in more detail in order to try to figure out what the future will be like. And in so doing, the most recent surprise is that we've found that the current rate of expansion is higher than expected, even taking into account the known acceleration. So that's really weird. What is it caused by? We don't really know. There's a number of possibilities, but I'm out of time. So just stay tuned. This result is very interesting. It's rocking the world of cosmology once again, as we did in 1998 with the discovery of the acceleration. So a big thank you to my undergrads, grad students, and postdocs who have helped me do this work over the years, and of course, to the various funding agencies that supported this research. And once again, congratulations to all Science Olympiad participants and award winners. Long live and prosper in STEM fields. Thank you so much for your attention. Bye-bye.
Thank you, Dr. Filipenko. Next, we have a short message from one of our sponsors. Keith Mack is the president of PEG, the Professional Engineers in California Government. PEG represents the thousands of state-employed engineers and related design professionals who design and inspect California's infrastructure, improve its air and water quality, and develop clean energy and green technology. Mr. Mack's state service career spans 15 years, all of them with Caltrans. He has served as a PEG leader for more than a decade during that time. While he started off designing infrastructure projects, today Mr. Mack works at Caltrans headquarters, where he is a senior transportation engineer responsible for training and developing the hundreds of new engineers who are hired each year. He served in the U.S. Air Force Reserve's 940th Civil Engineering Squadron before joining Caltrans.
Hello, I'm Keith Mack, President for the Professional Engineers in California Government, known more simply as PEG. Our organization represents nearly 14,000 state engineers, architects, geologists, and related professionals who apply scientific principles in pursuit of real-world solutions. The state highways and the bridges that connect the Bay Area, we designed them. Your schools and your local hospitals, we're the architectural experts that make sure that they stay strong and protect you in the event of an earthquake. And all the cars you see on the road, we also hold manufacturers accountable for meeting California's tough emission laws. That way our air stays clean. PEG is a very proud sponsor of this year's Golden Gate Science Olympiad. And although I can't see you, I want to let you know that I'm very honored just to spend a few moments speaking with some of the best and brightest students in the state. Like you, I appreciate the Science Olympiad National Award winners who collaborated with UC Berkeley and Stanford to make this event possible. Their pay it forward spirit is what made the event happen 5 years ago, and I'm sure it's going to be here for years to come. Of course, praise should also be given to family, friends, and loved ones, those who supported you, and the educators who guided you, and also the volunteers who organized and operated the event. I know you join me in thanking them too. From my experience as a state engineer, I can tell you that the traits you displayed during the Olympiad are the very things that would make you a great public servant if you choose to go that route. I graduated from Chico State more than a dozen years ago and went on to design great transportation projects that are still in use today. And now I get to help train the next generation. Hundreds of engineers have joined the state workforce, and they're helping us now to maintain and improve our infrastructure. Some of you may think the state engineers concern themselves with little more than roads, highways, and bridges. Well, actually we do far more than that. Some work on green energy projects, some work on providing water to 1 million Californians without it, and check dams, or they check workplaces for unsafe conditions. In a recent example, state engineers caught the world's second largest auto manufacturer making cars that secretly emitted up to 40 times the legal limits of pollutants. Billions and billions of dollars of fines were paid, the executives went to jail, and the polluting cars were taken off the road. It was in the headlines, and it was actually included in a Netflix documentary series called Dirty Money. Now, your participation in the Olympiad tells me that you have the interest and the talents that could someday unlock solutions to today's greatest challenges. Nurture those interests and pursue your education, the job possibilities in engineering, technology, science, and math are virtually limitless. And who knows, maybe one day soon I'll see you in the state workforce. So on behalf of the professional engineers in California government, congratulations to this year's Golden Gate Science Olympiad Award winners.
Thank you, Mr. Mack. Finally, our last speaker is Anna Koperniku from the Department of Chemical and Systems Biology at Stanford, another one of our sponsors this year. Dr. Koperniku obtained her Bachelor's of Science in Pharmacy in 2011 and Master's of Science in Pharmaceutical Chemistry in 2013 from National and Capodaustrian University of Athens. In 2013, she started at UBC as a PhD student, and her doctoral thesis focused on the chemistry of N-silated amines as precursors to pharmaceutically relevant small molecules in the groups of professors David Gearson and Laurel Schaefer. She was an NSERC Create Sus-Syn and a 4-year doctoral fellow at UBC. She is currently a postdoctoral fellow in drug discovery in the Moshley Rosen Laboratory at Chemical and Systems Biology at Stanford University, where she is working on the identification of small molecules to correct enzymopathies. In her message, Dr. Koperniku talks about her own journey through STEM and the importance of chemical and systems biology research.
My journey in science starts back in 2006, when I was firstly introduced into the meaning of a drug as a therapeutic. The essential trifold of drug discovery encompasses drug design, drug synthesis, and drug evaluation. And if you've achieved all three of them, then you shall celebrate yourself. What follows after drug discovery is drug development, and it is equally important to drug discovery. With drug development, a drug is transformed into a therapeutic. Here, in this video, I am going to share with you my contribution in drug discovery at the Chemical and Systems Biology. During my doctoral studies, I learned chemistry. And with chemistry, we know how to access the pharmaceutically relevant small molecules. We know how to make the small molecules. Here at the Chemical and Systems Biology, I'm employing that expertise into the context of identifying small molecules which will activate G6PD and ALDH2. G6PD and ALDH2 are two enzymes whose deficiency is associated with the two most common enzymopathies in the world. And this rank among the world's population clearly highlights the importance for the identification of the small molecules to treat and at our best to cure the phenotypes associated with G6PD and ALDH2. And in particular, the phenotypic expression of G6PD is hemolytic anemia, while for ALDH2 is the alcohol flushing, which is due to the accumulation of toxic aldehydes. Here at the Chemical and Systems Biology, I've been given the opportunity to acquaint myself with the Schrödinger software. In this software, you can dock the envisioned compounds into the designated pocket, and this, as a process, allows for rational drug design. Here at the Chemical and Systems Biology, I've also been trained in drug evaluation in vitro assays in order to test the synthesized compounds. So it's at this department that I'm bridging what precedes and what succeeds the drug synthesis in order to identify a hit, a molecule which will then be transformed into a therapeutic, and to let my audience know about what happens next is that once a compound is shown in vitro activity, then it is tested in animals, and these animal studies correspond to the preclinical studies. If given the green light in the preclinical studies, then the drug is moved into human clinical trials those clinical trials, 1 to 3, allow for the validation of the efficacy and toxicity of those small molecules. It is at those stages that the formulation and the route of administration of the drug or the therapeutic is decided. I'm confident I provided you with a taste of what both drug discovery and drug development can mean to humankind.
Thank you, Anna, for that lovely introduction to your work with our sponsor, the Stanford Department of Chemical and Systems Biology. Next, I'd like to pass it off to our PR team, Allison, Martin, and Iris.
Hello, everybody. We are excited to introduce ourselves as the team behind all of GGSO's marketing initiatives and the organization's digital presence at large. My name is Allison, and I am a tournament director over at UC Berkeley.
My name is Martin, and I'm a tournament director across the bay at Stanford.
And I'm Iris, and I'm also a tournament director from Stanford.
So first off, be sure to follow GGSO on all our social media platforms so that you can stay up to date with the latest. You can find us on Instagram at Golden Gate Scioli, Facebook at Golden Gate Invitational, Twitter at Golden Gate SO, and Snapchat at GG Scioli. Next up, a huge congratulations to Jackie Chang of Milpitas High School, winner of our 2021 GGSO t-shirt design contest. We were incredibly excited to receive so many standout submissions, so a big thank you to all who submitted your amazing designs. Jackie's design is featured on our 2021 Golden Gate Invitational t-shirt, which is the giveaway prize for this year's GGSO social media contest. And now for our winners of this year's free GGSO t-shirt prize giveaway series.
This week started up with my favorite challenge, guessing Martin's or my height. Back in the early days of meeting in person, group photos with GGSO were always a challenge for both myself and my knees. Either way, I was very glad to see all the guesses on our post, including the correct guess from our winners. As our graphics creator, Tuesday's challenge was a great way to see which posts have been the most popular among all of you. I had no idea National Moon Day was one of your favorites. This year, we'll definitely have to post Capybara Appreciation Day as well. As a current tournament director, some of these questions were a challenge even for me. For those who are curious, the squid has been our long-standing mascot due to the GGSO logo's uncanny similarity to the top of the cephalopod. However, through my own advocacy, the capybara is our new up-and-coming mascot.
Our last challenge for the week was a round of GeoGuessr GGSO edition. Although most of our directors are concentrated in the Bay Area, we're really excited to have members hailing from states all over the country. We always love to see what our directors do when they go travel. For this day's challenge, we had participants guess the names and locations of some of our most popular director photos. We were really excited to see everyone's guesses, including those of the winners below. Lastly, a huge thank you to all of our participants. Regardless if you won or not, your engagement support is what keeps us running. For winners, look out for a direct message very soon with instructions on how to claim your prize. And for everyone else, please make sure again to follow all of our social media platforms to stay on top of GGSO news and also to participate in future challenges. Thank you.
Hi everyone, I'm Martin Altenberg, one of the GGSO tournament directors. First off, I just wanted to applaud all the competitors, as well as all the coaches, parents, event supervisors, and volunteers for all of your hard work, and especially for sticking with us through all the issues on tournament day last weekend. And now for the moment everyone has been waiting for. We are finally announcing the awards for the 2021 GGSO Invitational. We'll be announcing the top 10 teams for each event. And just a heads up, some of the events will have asterisks by their name. And these are our trial events, which include biophysics, designer genes, and write a cadet. Okay, now, without further ado, let's get started on the award ceremony. First up, anatomy and physiology. In 10th place, Mountain View, Team Gold. In 9th place, Troy, Team A. In 8th place, Lexington, Team A. In 7th place, Brookwood, Team A. In 6th place, West Windsor, Plainsboro North, Team East. In 5th place, Mason, Team Gate. In 4th place, Carmel, Team Blue. In 3rd place, Northville. In 2nd place, Hillsboro, Team A. And in 1st place, we have Mountain View, Team Black. Congratulations to everyone in anatomy and physiology. Our second event is astronomy. In 10th place, we have Mission San Jose, Team Lime. In 9th place, we have Commerce, Team CHSO. In 8th place, we have Solon, Team A. In 7th place, we have Mountain View, Team Black. In 6th place, we have Brookwood, Team A. In 5th place, we have Adelaide E. Stevenson, Team Green. In 4th place, we have Iolani, Team Simple. In 3rd place, we have Lexington, Team A. In 2nd place, we have West Windsor, Plainsboro North, Team East. And finally, in 1st place, we have Mason, Team Gate. Congratulations to everyone who competed in astronomy. Our next event is biophysics, a trial event. In 10th place, we have Carmel, Team Blue. In 9th place, we have West Windsor, Plainsboro South, Team West. In 8th place, we have Hillsboro, Team A. In 7th place, we have University. In 6th place, we have Tesla STEM, Team Green. In 5th place, we have William P. Clements. In 4th place, we have Lynbrook, Team Red. In 3rd place, we have Adelaide E. Stevenson, Team Green. In 2nd place, we have Iolani, Team Simple. And in 1st place, we have West Windsor, Plainsboro North, Team East. Congratulations to everyone in biophysics. Our next event is Chem Lab. In 10th place, we have Lake Braddock. In 9th place, we have Iolani, Team Simple. In 8th place, we have University. In 7th place, we have Dublin. In 6th place, Mountain View, Team Black. In 5th place, West Windsor, Plainsboro South, Team East. In 4th place, Mason, Team Gate. In 3rd place, Basis. In 2nd place, West High, Team Kiwis. And in 1st place, we have Seven Lakes, Team Blue. Congratulations to everyone in Chem Lab. Next up will be Iris to present our next events.
Hi everyone, the next event is Circuit Lab. So without further ado, in 10th place, we have Camas High School. In 9th place, Mission San Jose, Lime. In 8th place, Lower Marion. In 7th place, West Windsor Plainsboro South, Team West. In 6th place, West Windsor Plainsboro North, Team East. In 5th place, Mountain View, Black. In 4th place, Mason, Team Gate. In 3rd place, we have Adley E. Stevenson, Team Green. In second place, Seven Lakes, Team Blue. And in first place for Circuit Lab, we have James S. Rickards, Team 1. Congratulations. For the next event, we have Codebusters. In 10th place for Codebusters, we have Orange County School of the Arts. In 9th place, Tesla STEM Team Green. In 8th place, we have West High Team Kiwis. In 7th place, William P. Clements. In 6th place, we have Northwood. In 5th place, Valencia Team Gold. In 4th place, Seven Lakes Team Orange. In 3rd place, we have Irvington Team Azure. In 2nd place, Mission San Jose Lime. And in 1st place, we have Mountain View Black. The next event is Designer Jeans. So as a reminder, this is a trial event, so teams will be receiving medals but will not count towards the team placings. In 10th place for Designer Jeans, we have Monta Vista Team Purple. In 9th place, we have Carmel Team Blue. In 8th place, we have Iolani Simple. In 7th place, William P. Clements. In 6th place, West Windsor Plainsboro South Team West. In 5th place, we have West Windsor Plainsboro North Team East. In 4th place, we have Mission San Jose Lime. In 3rd place, Ed W. Clark Team Black. In 2nd place, Limbrook Blue. And in 1st place for Designer Jeans, we have University. Congratulations. The next event will be detector building. In 10th place, we have Hillsboro A. In 9th place, St. Francis Team Gold. In 8th place, William P. Clements. In 7th place, James S. Rickards Team 1. In 6th place, West High Kiwis. In 5th place, West Windsor Plainsboro South Team East. In 4th place, West Windsor Plainsboro North Team East. In 3rd place, Solon A. In 2nd place, Mountain View Black. And in 1st place, we have Canyon Crest Academy Team Red. Congratulations to detector voting winners. The next event will be digital structures. In 10th place, we have Troy A. In 9th place, Mason Team Gate. In 8th place, Mountain View Black. In 7th place, Lexington A. In 6th place, Monta Vista Team Purple. In 5th place, Amador Valley Team Emesis. In 4th place, Castro Valley Team Gold. In 3rd place, Hillsboro B. In 2nd place, Sarasate High School Team A. And in 1st place for digital structures, West Windsor Plainsboro North Team East. The next event will be disease detectives. In 10th place, Mason Team Gate. In 9th place, Iolani Simple. In 8th place, University. In 7th place, Carmel Team Blue. In 6th place, Adlai E. Stevenson Team Green. In 5th place, Seven Lakes Team Blue. In 4th place, Hillsboro A. In 3rd place, Limbrook Blue. In 2nd place, Mountain View Black. And in 1st place for disease detectives, we have American Team Blue. Congratulations. I will be now passing it off to Emily to announce the next few events.
And our next event is Dynamic Planet. In 10th place, we have Lower Merion High School. In 9th place, Mountain House Team Blue. In 8th place, Mason Team Gate. In 7th place, Mountain House Team Silver. In 6th place, we have Troy Team A. In 5th place, Mountain View Team Black. In 4th place, we have Tesla STEM Team Green. In 3rd place, West Windsor Plainsboro North Team East. In 2nd place, Lexington Team A. And in 1st place, the winner of Dynamic Planet, we have Lynbrook Team Blue. Congratulations. And for our next event, we have Experiment and Data Analysis. In 10th place, we have Mountain View Team Black. In 9th place, Lynbrook High School Team Blue. In 8th place, Portola Team B. In 7th place, James S. Rickards Team 1. In 6th place, we have Milpitas Team Blue. In 5th place, Diamond Bar. In 4th place, Troy Team A. In 3rd place, Carmel Team Blue. In 2nd place, Ed W. Clark Team Black. And in 1st place, the winner of Experiment and Data Analysis is Carmel Team Gold. Congratulations to all participants. And for our next event up, we have Forensics. In 10th place, we have Seven Lakes Team Orange. In 9th place, Carmel Team Blue. In 8th place, West Windsor Plainsboro Northeast. In 7th place, William P. Clements. In 6th place, Mission San Jose Marigold. In 5th place, Mountain View Team Black. In 4th place, Great Oak Team Wolfpack 1. In 3rd place, Glenn A. Wilson Team Cardinal. In 2nd place, Mason Team Gate. And in 1st place, the winner of Forensics is Adlai E. Stevenson Team Green. Congratulations to all participants. And for the next event, we have Fossils. In 10th place, we have Mountain View Team Black. In 9th place, Mason Team Golden. In 8th place is American Team Red. In 7th place is Canyon Crest Academy Team Red. In 6th place, we have Mason Team Gate. 5th place is Monta Vista Team Purple. In 4th place, we have Ed W. Clark Team Black. In 3rd place, Lexington Team A. In 2nd place, West Windsor Plainsboro North Team East. And the winner of Fossils is Troy Team A. Congratulations. And for our next event, we have Geologic Mapping. In 10th place, we have Mason Team Gate. In 9th place, we have Mission San Jose Team Lime. 8th place is Seven Lakes Team Blue. 7th place is Carmel Team Blue. 6th place is Mountain View Team Black. In 5th place, we have Lynbrook High School Team Blue. In 4th place, we have West Windsor Plainsboro South Team West. In 3rd place, we have Harrington Team B. In 2nd place, we have Tesla STEM Team Green. And in 1st place, we have West Windsor Plainsboro North Team East. Congratulations. And for the next event, up is Machines. In 10th place, we have Mission San Jose Team Lime. In 9th place, we have West Windsor Plainsboro South Team East. In 7th place, we have Seven Lakes Team Orange. In 7th place, we have Carmel Team Blue. In 6th place, we have West Windsor Plainsboro North Team East. In 5th place is Mountain View Team Black. 4th place is Tesla STEM Team Green. 3rd place is Seven Lakes Team Blue. And in 2nd place, we have West Windsor Plainsboro South Team West. And the winner of Machines in 1st place is Mason Team Gate. Congratulations. And now I'll pass it off to Nicole to announce the remaining event awards.
All right, next up, we have ornithology. In 10th place, For ornithology, we have Camas High, Team CHSO. In 9th place, Adlai E. Stevenson, green. In 8th place, Palo Alto, white. In 7th place, Mason, Gate. In 6th place, West Windsor, Plainsboro North, east. In 5th place, Harrington, A. In 4th place, Ed W. Clark, black. In 3rd place, Seven Lakes, blue. In 2nd place, Troy, A. And the winners of ornithology this year are Lexington, A. Congrats to all the winners for ornithology. Next up in the events are protein modeling. In 10th place, we have Seven Lakes, blue. In 9th place, we have Lexington, A. In 8th place, American, blue. In 7th place, Mason, Gate. In 6th, Adlai E. Stevenson, green. In 5th place, Mountain View, black. In 4th, Iolani, simple. In 3rd, Hillsboro, A. In 2nd, Brookwood, A. And the winners of protein modeling this year are Limbrook, blue. Congrats to all the winners for protein modeling. The next event we'll be moving into is Sounds of Music. In 10th place, we have Camas, Team CHSO. In 9th place, Tesla STEM, green. In 8th place, Portola High School. In 7th place, Seven Lakes, blue. In 6th place, Mountain View, black. In 5th place, Adlai E. Stevenson, green. In 4th place, American, blue. In 3rd place, Mason, Gate. In 2nd, West Windsor, Plainsboro North, east. And the winners of Sounds of Music this year is West Windsor, Plainsboro, southeast. Congratulations to all the winners for Sounds of Music. The next event that we'll be heading into is water quality. In 10th place, we have Mountain House, blue. In 9th place, we have Seven Lakes, blue. In 8th place, Portola High School. In 7th, Mason Gate. In 6th, Salone, B. 5th, Liberal Arts and Science Academy, Team A. In 4th, Mariloma, blue. In 3rd, Carmel, blue. In 2nd, Lexington, A. And the winners of water quality this year are Troy, A. Congratulations to all the winners for water quality. And finally, the last event, but certainly not the least, we have Write It, Cat It. Just a reminder, this is a trial event, hence the asterisk by its name. All right, in 10th place for Write It, Cat It, we have Troy, B. In 9th place, Brookwood, A. In 8th place, American, blue. In 7th place, Mountain View, black. In 6th place, Limbrook, blue. In 5th place, Lake Braddock. In 4th, West Windsor, Plainsboro North, east. In 3rd, Mountain View, gold. In 2nd, Portola High School. And the winners of Write It, Cat It this year are Ed W. Clark, gold. Congratulations to all the winners of Write It, Cat It. And finally, we'd like to congratulate all our winners and to all the competitors for doing a wonderful job. And last but not least, just a final announcement. Coaches, please do remember to fill out our medals and trophies form to get all your medals mailed out to you after the ceremony. Thank you so much.
And before we jump into trophies, we just like to take a moment to give a very special shout out to the amazing seniors on our team.
Allison is a tournament director from UC Berkeley and has been with GGSO for 4 years. She has made so many contributions over the years, but perhaps her biggest legacy is pioneering the role of public relations and marketing with our social media platforms. I'm so inspired by everything you do for the causes that you're passionate about, and I know you'll do amazing wherever you go. Thank you.
Faith joined GGSO during the 2017-2018 season as an event supervisor and has since served as the Director of Communications and Sponsorship. Thank you for all of your contributions to GGSO, as well as being an amazing mentor to me and providing me help throughout the year with the inbox.
Martin first joined the board last season and has since served as a Director of Communications, PR, and Tournament Development. Thanks for all you've done to put together amazing designs for our Instagram, and it's been really fun working with you to make this award ceremony come to life.
Evelyn first became involved with GGSO as an event supervisor for disease detectives, as well as a test evaluation committee member for our 2018 tournament. She then joined the board and served as the Director of Events for the next 2 years. It's been a pleasure working with Evelyn as co-executive directors for this year's tournament.
Thank you, Allison, Faith, Martin, and Evelyn for everything you've done for GGSO. And now I'll pass it off to two of our seniors, Allison and Faith, who will be announcing the final team rankings.
Good afternoon, everyone. My name is Allison, and I am a tournament director at UC Berkeley. I'm pursuing a simultaneous degree in molecular environmental biology and psychology with a minor in Chinese.
Hello, everyone. I'm Faith, also a tournament director at Stanford. I'm double majoring in mechanical engineering and Russian.
And now for the finalized team placements you've all been waiting for.
School rankings. Coming in 10th place, we have Hillsborough.
In 9th place, we have Adelaide E. Stevenson.
In 8th place, we have West Windsor Plainsboro South.
In 7th place, we have Lexington.
In 6th place, we have Carmel.
In 5th place, we have Troy.
In 4th place, we have Seven Lakes.
In 3rd place, we have West Windsor Plainsboro North.
In 2nd place, we have Mason.
And in 1st place, for the 2021 Golden Gate Science Olympiad Invitational Tournament, we have Mountain View. Congratulations to all of our competitors and teams for participating in the 5th annual Golden Gate Invitational. And we would also like to extend our deepest gratitude to all members of the GGSO community for making this tournament possible.
Thanks again for attending our first ever virtual tournament, and we hope to welcome you in person to our next year's 6th annual Golden Gate Invitational.
Thank you all for watching. We have a few reminders before we end tonight. Graded copies of the tests can be found on SciOlympiad, and this full score sheet can be found on our website. Teams will receive PDF copies of the blank tests and keys after we receive at least one survey response from both a student competitor and their coach. This year, we will be having a score review period. Teams will have until 5 p.m. Pacific time on Monday, February 22nd to notify us of any major result discrepancies, such as incorrect no-shows, disqualifications, or clerical errors. The score review period will not be accepting any regrade requests for students contesting question rubrics. After the score review period is over, our results will be considered final. We hope you all enjoyed this year's award ceremony and hope to see you all again next year.